Example 1, sketch the graph of f of x equals absolute value of x plus 3. Now that yellow sheet of paper I handed out yesterday, the lesson 110 notes, gives you the ordered pairs for the parent function of the type of function we're dealing with. So first thing I want to do is identify from the function here that it's an absolute value function. So you go to the parent graph sheet there and find the absolute value. And you'll see that if we have an absolute value function for the parent graph, negative 2, negative 1, 0, 1, 2 gets me 2, 1, 0, 1, 2. All right, so that set of ordered pairs is set in stone. That's the parent function anytime you see absolute value of x happening. Or for that matter, absolute value of anything happening. That's your initial setup as long as x is the first power. We're not going to get beyond that in this class. And I want to plot the parent function first, and I'm going to plot these points, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. And then we graph an absolute value function by starting at it's called the cusp. It's the sharp point where the graph turns direction. So you want to go with a straight line coming that direction and a straight line coming that direction off of the cusp. So that's what an absolute value function looks like to start off with. So that's the parent. And I'm going to put a P next to that to represent that's the parent graph. Now, one of three things is going to happen to our functions today. Let me show you the three possible things that might happen. I'll go to the new page to do that. We're either going to do, let's just say we have f of x to begin with. We're either going to do f of x plus some number, we're going to do f of x plus some number, or we're going to do negative f of x. Or some combination of those three things. All right? The first thing we want to deal with is the negative. If the function f of x, for example, f of x in this case is an absolute value type function, our parent function f of x is an absolute value. If I go with negative absolute value of x, that's negative f of x. Okay? What that does is it reflects over x-axis. And that's the first thing you're going to deal with. If there's a minus in front of your function, reflect the parent function. The other two things you can deal with at the same time, if we change, so let me just maybe use some different colors here. So this one here we'll do in red. We'll just do all these with an absolute value. It could be x cubed, x squared, square root of x, whatever. It's whatever the function is to begin with. But there's the function, put a minus sign in front of that, it's reflecting over the x-axis. We'll do this one here in green. Maybe, there we go. Okay, if you take a function and add a number to it, it's going to move. My board's not cooperating with me right now. It will move vertically positive A spaces. When I say positive A spaces, that means whatever A's sign is, it's going to move that way. So if it's plus 5, it moves up 5. If it's minus 2, it moves down 2. Okay, so that initial set of points, that parent function, is going to either go up or go down as a whole unit. The other possibility is that we're modifying inside. So what this looks like, this here would look like absolute value of x plus 3. Look familiar? Absolute value of x plus 3. All right, so you take the absolute value of x, it's done, and then plus 3 happens outside of it. What this one here looks like, f of x plus a, it'll be absolute value of x plus 3 inside the absolute value bars. And it's going to move horizontally negative A spaces. In other words, change the sign. So this right here, if I did absolute value of x plus 3 inside the absolute value bars, that would take the parent function absolute value of x, the one we just graphed here, and it would slide 3 spaces to the left. So those are the scenarios, those are the things that can happen. So in order to graph these functions right now, what I want to use is the parent function. It's an absolute value function, graph the parent function, and then apply the changes to it. So This change is a +3 outside the absolute value bar. So that's a vertical shift. It's going to go +3 vertically. So what's going to happen is every one of these points that I plotted, 1, 2, 3, 4, 5 points, all move up 3 spaces. 1, 2, 3 spaces up. 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 And 1, 2, 3 spaces up. And we connect those dots the same way. And then I'm going to put a capital F next to that one to identify that's what I'm calling f of x. Once I've done all the changes necessary, I just simply put it up there. So that's what I want your answers to look like in this section for now. Graph the parent function and then apply the correct changes to get the actual graph that we're looking at.